Okay, metal carbonates. First question. Name the type of reaction that happens when a metal carbonate is heated. Well, you've just got to know this. Whenever you heat a metal carbonate, it decomposes. So the answer is thermal decomposition. Let's do an example. Let's do calcium carbonate. Okay. Calcium's a metal, so your bones are made of metal. You're like a Terminator, believe it or not. Calcium carbonate, heat it. Whenever you see carbonate, CO3 is carbonate, okay? Whenever you heat that, it's going to release CO2, okay? So what's left? That's CO3, the CO2 has gone, so that leaves one oxygen and the calcium. So calcium carbonate, when heated, decomposes to calcium oxide and carbon dioxide. Okay, next question. Which solid product is formed when copper carbonate is heated? Well, let's do that as well. Copper carbonate, heat it. Same thing, you're going to get copper oxide and carbon dioxide. That's a solid, that's a gas. So the answer, what solid is formed, it's copper oxide. Make that look a bit more like a U. Okay. Right, next question. It's this thing here. We have to explain the results for potassium carbonate. Okay, so what we're doing is heating the metal oxide for 5 minutes and then weighing it again and seeing its weight after being heated for 5 minutes. So the results for potassium carbonate were, there was 10 grams left after heating for 5 minutes, and it started with 10 grams as well. And also we were told that the lime water doesn't go cloudy, and that's it. Now you have to extract 3 marks of this question, which is, it's not a particularly difficult question, but getting 3 marks out of it is quite tricky. So you have to use exam technique, say as much as you possibly can. Okay, so the first thing to say is that there were 10 grams before and after, so it didn't react. Okay, now looking at the mark scheme, that actually gets you 2 marks, and this is what I mean by it's difficult to get all 3 marks from a fairly easy question. It's conceptually easy, but difficult to get the maximum marks, if you see what I mean. Apparently, they give you 1 mark for saying the potassium carbonate didn't react, and they give you a 2nd mark for saying there was no mass change. Well, you can infer that it didn't react because there's no mass change. So I wouldn't blame you for just saying it didn't react and not mentioning the mass change. Anyway, my point is this: exam technique is really important, and it can be the difference between 1 or possibly 2 grades. So the lesson is, write down everything you can think of, even what might seem the really obvious. It's really obvious to say, well, there were 10 grams at the beginning and 10 grams at the end, but you get a mark for it apparently. So this is true for all sciences, all exams probably. Just write down the obvious to extract the maximum marks. So to get the 3 marks, you have to say the potassium carbonate didn't react, there was no mass change, and also the lime water didn't turn cloudy. So that means that there was no carbon dioxide released. Say that as well. Okay. Lime water turns cloudy when carbon dioxide has bubbled through it. You need to know that. Okay. Moving on. Right. Suggest how the reactivity series can be used to predict which metal carbonate reacts most easily when heated. Okay. You need to know your reactivity series for this question. So I've written it down here. There it is. Potassium, sodium, calcium, and so on. It always helps, I think, to remember things like this using a mnemonic. So what's wrong with this mnemonic? It's a pretty good one. Please stop chasing mice and cats, Zebedee. I have caught some goats. It's as good as any. There are loads of mnemonics for the reactivity series out there. Pick your favourite, but this one will do. I hope you like it. Okay, so what have we got? Well, the copper carbonate had the lowest amount, the lowest mass. I shall be accurate with my terminology, after being heated for 5 minutes. So the copper carbonate was there. That had the, I'll call that 1. It had reacted the most. The next is zinc carbonate there. That had reacted the second most. Then magnesium carbonate had reacted a bit. And then the potassium was in last place. It hadn't reacted at all, the potassium carbonate. Okay, so look, we've got a pattern. The one that reacted, the carbonate that reacted the most had the least reactive metal. So that's the answer. So say that the more reactive the metal, the slower the carbonate reacted, or the less the carbonate reacted. Or if you like, the other way round, the more reactive the metal, the slower or the less the carbonate reacted. Good. Like I say, you do need to know your reactivity series for that, so learn it. Right, next. Iron ores must contain enough iron to make it economical to extract. That was the answer. Complete the following sentence. Iron ores must contain enough iron to what? This is a stupid question. I mean, there's so many things you could say. How are you supposed to know that the only thing that gets you the mark is saying iron ores must contain enough iron to make it economical to extract the iron? Well, that's the answer, so just remember that, okay? The reason iron ore is extracted in the first place is because the iron ore has to contain enough iron to make it worthwhile, economically. Anyway, let's move on. Complete and balance this equation to produce iron ore from iron oxide. Right, the equation is iron oxide and carbon, some number of carbons, some number of oxides, go to something and some CO2s. CO2. Ignore that. Okay, so we've got to put a number there, work out what that is, and put a number there. Well, they've helped you a bit here because they say this is the equation to produce iron from iron oxide. So there's going to be iron somewhere on the right. So it's got to go there. Okay? They tell you in the question that iron is being produced. So that's what the blank must be. Especially because, look on the left, the atoms are iron, oxygen and carbon. We've got carbon and oxygen there, so the iron must be there. Okay. So this is what happens in a blast furnace. Now we've got to balance it. So let's start with the first one, iron. There's 2 ions on the left, so let's try putting a 2 there. Well, now the ions are balanced, so let's go back to the beginning and see about the oxygens. There are 3 oxygens on the left and there's 2 on the right. Okay, we can't just add a single number in this case because 2 doesn't go into 3, so we have to add 2 numbers. Let's multiply the 3 by 2 and the 2 by 3, because now we've got 6 oxygens on both sides. Okay, that's the trick, and the thing you have to do in that case. Right. But that 2 is interfering, well, multiplying the ions. We've now got 2 times 2, we've got 4 ions on the left, which means that 2 is now wrong. So what we do is change it into a 4. Okay, 2 times 2 on the left. So now we'll change that into a 4. So now the ions and the oxygens are balanced. So move on to the next one, carbon. How many carbons on the right? We've got 3 times C there. So there's 3 carbons on the right. So if we put a 3 there, we should have balanced it. Let's check. Ions, 2 times 2, 4 on the left, 4 on the right. Good. Oxygens, 2 times 3, 6 on the left, 3 times 2, 6 on the right. Good. Carbons, 3 on the left, 3 on the right. Okay, so that's it. That's the equation balanced. Good. Next question. By the way, when balancing equations, you're only allowed to add big numbers at the beginning. You're not allowed to interfere with the little numbers. Okay? Anyway, moving on. Give 2 reasons why iron produced in a blast furnace is converted into steel. So they're asking, why don't we just leave it as iron? What's better about steel than iron? Steel is mostly iron, but there's a little bit of carbon introduced to the iron to turn it into steel. I think it's about 2% carbon. So steel is about 98% iron, 2% carbon. But iron is pure iron. Right. 2 reasons why iron produced in a blast furnace is converted into steel. Well, firstly, steel is stronger than iron. Okay, so that'll get you a mark. Steel is more rust resistant. Okay, and there's one more. Oh yeah, iron is more brittle. Or iron is, probably better to say iron is brittle. Don't say more, just say iron is brittle and steel is more rust resistant. Steel still rusts, but slower than iron. Okay, so pick 2 of those 3 and that'll get you your 2 marks. Next question, final question. Give 3 reasons why a steel car body should be recycled and not reused or sent to a landfill. 3 marks. Again, I'm sure you probably can think of 1 or 2 reasons why this should happen, but extracting 3 marks from this is not easy. It's exam technique, so you've got to just say anything you can think of, and as usual, the normal rules apply. Say the obvious and you might get a mark for it. So, why a steel car body should be recycled? Okay, well firstly, let's focus on that. Why should it be recycled? Well, that's the best way to put this. It should be recycled because it conserves limited iron ore. It also conserves energy. Okay, 1 mark. Right, give 3 reasons why a steel car body should be recycled and not reused. Okay, why shouldn't you reuse a car body? Well, because the steel in the car body can be fatigued or damaged or could have rusted. Okay? And finally, why should it not be sent to a landfill? Okay? It's best not to send it to a landfill because landfills have limited space. That's the best thing to say regarding landfills to get you the marks. You could say that they're harmful to the habitats of animals or the environment. Anyway, yeah, those are the 3 things that will get you your 3 marks. Okay, There we go. Thank goodness that question's over. Learn the reactivity series. Please stop chasing mice and cats, Zebedee. I have caught some goats.